In the chemistry crash courses, you will get the chance to cover specific topics, to get plenty of exam practice, but also to combine topics, because chemistry is all about logic, it's all about interlinking knowledge. And that's what we do in our group lessons: revise, refresh, or reinforce. I did one lesson on titration where with a very nice explanation of acid and base, back titration, and redox titrations. Imagine having all of these notes for you, being able to link between topics. They will give you really big help during the exam. For today, I would like to do with you a back titration explanation. Okay, and then together in this very special tutorial, we will practice the AQA past paper 2023 back titration, because you know what? It's going to be present in every paper. So it's very important to understand it. Also, you will have in an AS chemistry crash course, if you join, all of the AS topics come with plenty of practice. This worksheet is just for back titration. Imagine how many more there will be. But let's get started with a very brief explanation before we get practice. So back titration, we need to really understand the concept and make it very simple. So imagine that you enter a shop and you will exit the shop with a certain amount of money, and you want to know how much you spend. You're just going to have to find the difference between your initial amount and your final amount to understand the amount that you spent. So essentially, this is the core concept of back titration. You have one reaction, you end up with another reaction in order to find something in the middle. That's why it's back. We kind of go back. I want you to keep this in mind as we look at more examples. So just looking at the purpose of back titration, well, it's used when the reaction between the analyte and the titrant is slow and incomplete. So there could be, this could be a very nice suggest question, suggest why back titration is used to identify blah, blah, blah. Okay, so those are this type of question that you don't know exactly the content because they don't teach it to you, you just need to use the logic. Okay, but that's why I highlight this thing in our explanations. Okay, so it's also useful for substances that don't have a suitable indicator or that they're very volatile. So it means that they evaporate very quickly. So we need a very quick reaction. Okay. And also is when the reaction of the analyte and the titrant is low or incomplete. Yeah. So the method of back titration, let's look at the procedure and the calculation. Remember, this is a bit of a general, but you will see how each question, you can kind of think it this way. So the method of back titration, the procedure, unknown excess of a reactant is added to the sample containing the analyte. The reaction between the excess reactant and the analyte is allowed to proceed. The remaining excess reactant is then titrated with another reactant of known concentration. So first reaction, second reaction. You're going to be able to find the excess reactant. You will have an initial amount so that you can find the amount that reacted. Let's look in more detail about the calculation. So the amount of excess reactant used in the first reaction is determined. I like to call it the initial. So actually, this is the excess reactant, and it will be the last reaction that you have in the explanation. The remaining excess reactant is quantified through titration, allowing the determination of the amount reacted with the analyte. Okay, so again, this is all leads to find the amount in excess. And then the difference between the initial and the excess, it gives you the amount of the analyte that reacted. Okay, so I want you to think about these three steps. So let's try. I want you to read this question. I hope it's clear enough. But this was an AQA. AQA loves this type of very open questions. An exam style question, well, actually a past paper from 2017. I just want you to read this question and find this initial, this reacted, and this excess value. Okay, so just interpretation. I don't want you to get, the calculation. It's really the first important thing of back titration of any of them is to fully understand what is happening. Try to find this initial, this reacted, and this excess. Pause the video now because I will pause it also in our live lesson. So if you've played again this video, means that you had the time to think about this initial, reacted, and excess. Now, each titration in each question, it will be slightly different. So there is a lot of logic that is required, and you need to understand what is reacting with what, okay? However, there is always these three steps in common. Now, the initial amount, it will be whatever you mix at the beginning, okay? And it will be something that you can actually quantify, okay? And what do you notice? Whatever it will be your initial amount, it will be something related to this first equation. In fact, you will be able to find the potassium permanganate, okay? However, of course, this is all relative to these ethanedioic ions, which means that you will be able to find these specific ions. Now, this question is a bit tricky because you need to understand, wait, what are these ions? Because it would actually be the total of the salt and the acid. But that's your initial, that's the initial amount. Then the reactant is what you will have to come back to. So we'll be at the very end. But now you can think about, wait, what is in excess? What can I quantify after? And this is always from the second reaction. In fact, here you will notice that you will be able to quantify the amount of acid only. So how can you find the reactant? There is always going to be a difference here involved. And in fact, here you will be able to find the difference. You will be able to find the salt by doing the difference between the initial, which in this case is the total, and the excess, which in this case is, just the acid. But I just want you to think about, do you understand this initial reactant excess? Because we can never predict what we get in a paper. However, if you know a little bit where to direct your mind in terms of logic, it can really help. This was a very difficult question. So the reactant will be at the end the value of the salt. And this is at the end what you will need to take further. Because, so this is always the first part. Also, if you've joined my lessons before, I always talk about this like moles ratio moles concept, in the sense that you will always need to find the moles of something and find the moles of something else. And of course, you do it using the ratio. And anyway, this is the second part of the titration. Well, with the amount of moles that you found, in this case specifically of the reactant amount, you need to do something else. And most of the time, it would be calculating the percentage by mass. So of course, you needed to expand this further. If you have the moles, then you're going to have to find the mass. Sometimes you're asked to find the identity of a metal. Yes, so to do that, you will need to find the MR instead. Okay, so this can always be expanded. Okay, so it really depends on the question. Okay, so if you would like to try this full question, please pause the video and I will show you the marking scheme just right now. So pause it before I show you the mark scheme. Okay, so if you're ready with the mark scheme, this is it. You can actually take, I'm going to share it here actually. Feel free to take a screenshot if you would like to get each of the marks. Yeah, but I just want you to notice that the steps. Initial moles, it was this permanganate. Then we had the moles, the moles in excess. And now we have the difference. This is the part of the moles that reacted. And then notice that how we can expand everything else. One important thing to never forget about any titration is to think about the volumes. Always ask yourself in which volume, because this is such an easy mark to lose when you needed to find the moles in the original sample. Because most of the time, you will be given, you will know it because you will have in a mixture, blah, 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 in 250 centimeters cube, but then 25 centimeters cube were added, were used. Okay, so it really, as you read it, please try to notice that these are changes in volume, because you can either use your logic or use the dilution factor to find the moles in the original sample. Okay, easy mark to miss, but not if you know exactly where to look for. Okay, so going back to the mark scheme, this is the final answer. I hope you gave it a go, and let me know in the comments if you made it, if you got a different value. Let me know if you need any help with it. Please also comment. And otherwise, join my A-Level Chemistry exam preparation to prepare for your exam with confidence with me.